Hello everyone, welcome to the lecture on Module 4 Circuit Breaker. Introduction. So in the power system, it is often necessary to switch on or off the various electrical devices and the circuits like the generating plants, the transmission line, the distribution system, etc. in a normal operating condition or under the abnormal situation such as the faulty condition. So the task is performed by the switch and a fuse which is connected in series with the electrical circuit. So the main disadvantage of the setup which is used by the switch and the fuse is that if the fuse is blown when the fault occurs, it is often a time consuming to replace that or restore the power supply. And on the other hand, the main disadvantage is that the fuse cannot interrupt the heavy fault current. So these are the limitations which are restricted by the usage of the fuse and the switch combination, which are only applicable to a small voltage and a small capacity circuit. But in case of a high voltage and a large current system, a more desirable switch and fuse is replaced by with the help of a circuit breaker. So circuit breaker are used in case of a high voltage and large current system, wherein the switch and the fuse are used for the low voltage and a small capacity circuits. So here, this is what we are looking at, the relay part and the circuit breaker. So relay is what it is going to detect some abnormal condition and it is going to send a tripping signal to the circuit breaker. So after receiving the tripping command from the relay, the circuit breaker is going to isolate the faulty part of the power system. So this is the current transformer, this is the voltage transformer. So these are the two transducers which are connected to the relay. Now in the relay there is a preset value which is set again. So if the current, the normal current exceeds that preset value, then there's a fault occurred in the relay. So once the fault is occurred, the relay contact is going to close this particular tripping circuit. So the tripping circuit will consist of a trip coil and a battery. So once the relay is going to close a contact, the current is going to flow from the battery. So wherein the battery, because of the battery current, the trip coil is going to get energized. Therefore, the contacts of the circuit breaker are opened, thereby isolating the faulty part from the power system. So the circuit breaker consists of two contacts. One is the moving contact and one is the fixed contact. Now in this fixed circuit breaker chamber, we have some insulating medium. This insulating medium can be either an air, or it can be vacuum, or it can be oil, or it can be a gas such as sulfur hexafluoride, that is SF6, right? So based on the insulating medium which is used in the chamber of a circuit breaker, we can categorize the circuit breaker into the air circuit breaker, the vacuum circuit breaker, the oil circuit breaker, and an SF6 circuit breaker. So basically, a circuit breaker is a piece of equipment which is going to make, that is, it is going to carry or break a circuit either manually or by a remote control under a normal condition, or it can operate under a faulty condition. It can be also make or break either remotely or manually for the maintenance purpose. So the function of the circuit breaker is to isolate the faulty part of the power system in case of a abnormal condition such as a fault. So circuit breaker is a piece of equipment which we have discussed. It can make in sense it can carry or break a circuit either manually or by remote control under normal condition or under the faulty condition, or it can be either manually or can be remote control under faulty condition or under the maintenance purpose. Again, the circuit breaker, depending upon the insulating medium which is used in the circuit breaker chamber, that can be categorized into oil circuit breaker, air circuit breaker, air blast circuit breaker, sulfur hexafluoride SF6 circuit breaker, and a vacuum circuit breaker. So the basic function of the circuit breaker is to isolate the faulty part of the power system in case of a abnormal condition such as a fault. So here just there is a normal picturization of how exactly the relay and the circuit breaker is going to work out. So here this is a supply and this is the current transformer. This is connected to the relay, right? And this is the whole circuit breaker. Okay, it can operate manually or it can be operated automatically by a remote control. It has two contacts. One is the fixed contact and one is the moving contact, which is moving between the two sliding contacts. So this is indicating a moving contact. So whenever there is a fault taking place, this is going to get energized. As these are closed, it is going to open once the fault is taken place in the relay, thereby isolating the healthier system in the power system network. Now, the circuit breaker consists of two contacts, or the circuit breaker chamber has two contacts. One is the moving contact and the fixed contact. So whenever there's a fault which is occurring in the line, because of that, the contacts are which are placed in the closed chamber, which contains insulating medium, which can be a liquid, air, or gas. So once the breaker is going to operate, when the contacts are going to move, when the moving contact is going to move away from the fixed contact, between these two there will be an arc struck between these two contacts. So under the normal condition, the contacts remains in a closed position. So when the circuit breaker is required to isolate the faulty part, the moving contact is going to move away from the fixed contact to interrupt the circuit. So on the separation of these two contacts, an arc is formed between them and the current continues to flow from one contact to other contact through the arc. But still the arc is not yet extinguished or it is not yet quenched. So in order to quench the arc or extinguish the arc, the insulating medium which is present in the circuit breaker chamber is the essential part which can quench the arc in the circuit breaker chamber. So the circuit breaker chamber consists of a fluid which can be a liquid or gas. So because of that media, the circuit breaker can quench the arc. Fault clearing time of a circuit breaker. So there are two cases. Under the fault clearing time, we have the relaying time and the breaker interrupting time. Breaker interrupting time. So in the relaying time, at the instant of the fault, which is sensed by the relay, it's going to sense the fault and going to send the signal to the trip coil of the circuit breaker. So that is called as the relaying time. So once the relay is going to sense and it's going to send the signal to the trip coil of the circuit breaker, the battery is going to send the current to the tripping coil where it's going to energize and it is going to send the signal to the circuit breaker wherein the contacts of the circuit breaker are going to open. So that is called as breaker opening time at the instant of opening of arc contacts. So once the contacts are open, there is an arc formed between the fixed contact and the moving contact. So after this, so there's a time called as arcing time. So this is arcing time is going to stay between the fixed contact and the moving contact. So at the end of that, the arc is going to be extinguished by the use of insulating medium which is present in the circuit breaker chamber. So this breaker opening time and the arcing time is called the breaker interrupting time. And both together, the relaying time plus the breaker interrupting time is called as fault clearing time. Now we'll be looking at the arc voltage. Here, arc voltage is the voltage which is going to occur across the contacts of a circuit breaker. When the arc is still persisting, that is called as arc voltage. So the fault current or the short circuit current, so this is the short circuit current, is in phase with the arc voltage as the arc path is purely resistive. And the magnitude of this arc voltage is very low, typically around 3% of the rated voltage. Now we'll be looking at the arc phenomena. So when a short circuit occurs, a heavy current flows through the contacts of a circuit breaker. Now, at the instant when the contacts begin to separate, what is going to happen? The contact area decreases rapidly. Second, because of the decrease in the contact area, there will be a large fault current caused, which is going to increase the current density. And because of the increase in the current density, there will be a rise in the temperature. Because of rise in temperature, the heat is produced in the medium between the contacts is sufficient to ionize the air or the oil which is present in the chamber. The ionized air or the vapor is going to act as a conductor, and an arc is struck or formed between the contacts. The potential difference between the contact is quite small, and it is just sufficient to maintain the arc. So the arc is going to provide a very low resistance path. Consequently, the current in the circuit remains uninterrupted so long as the arc persists. So this is how the arc phenomena is going to occur between the contacts of a circuit breaker. Now, during the arcing period, the current flowing between the contacts depend upon the resistance. So what we have discussed is in this is that the arc provides a very low resistance path. Because of the low resistance path, the current in the circuit remains uninterrupted as long as the arc is going to persist. So the current flowing between the contact depends upon the arc resistance. So if the arc resistance is smaller, then the current flowing between the contact is going to increase. So great, if you increase the resistance, arc resistance path, then the current flowing between the contacts will be less. So the greater resistance, the greater the resistance, smaller the current that flows between the contacts. Now, the arc resistance is going to depend upon the three phenomena, that is degree of ionization. So if the arc resistance is increased with the decrease in the number of ionized particles between the contacts, then the arc can be quenched. Next, the length of the arc. If the arc resistance is increased with the length of the arc, again the arc resistance can be increased as R is proportional to rho L by A. So the resistance and the length are proportional to each other. If the length is increased, then the arc resistance increased. Because of that, the fault current can be decreased or the arc can be quenched. The third one is the cross section of the arc. So if the arc resistance increases with the decrease in the cross section of the arc. So again, arc is proportional to rho L by A. So A is resistance is inversely proportional to the area. If the area decreases, then the resistance increases. So that's why when the short circuit takes place, a heavy current is going to flow between the contacts of circuit breaker. So once a contact is going to separate, the contact area decreases rapidly. So the area has to be decreased. The cross section area of the arc has to be decreased. Then only the arc resistance can be increased. Now, what is the principle of an arc extinction? The factors that are responsible for the maintenance of arc between the contacts are the potential difference between the contacts, which is sufficient for the arc to exist as the separation between the contact is very less. Second one is the ionized particle between the contacts, that is the ionized medium can be an air or oil, have a tendency to maintain the arc. Now what are the methods of extinction? So the very first method is the high resistance method. So the arc resistance is increased with the time so that the current is reduced and finally the arc can be interrupted or it can be quenched. So in order to reduce or in order to use this high resistance method, we have three methods. The resistance of arc may be increased by again lengthening of the arc. So the resistance of the arc is directly proportional to its length. If the length of the arc is increased by increasing the gap between the contacts. B. We can cool the arc. Cooling helps in deionization of the medium which is present between the contacts. Therefore, the arc resistance increases. C. Reducing the cross section of the arc. So again, the cross section of the arc can be reduced by letting the arc pass through some arrow opening or by some having smaller area of contacts. D. Splitting of arc. Again, the arc resistance can be increased by splitting the arc into number of smaller arcs in series. So, the arc may be split by introducing some conducting plates between the contacts. This we'll study in when we look at the different types of circuit breaker. So, the high resistance method is not used cannot be used for high voltages. It is only used for AC DC current with a low power circuit. Now we'll be looking at the current zero interruption. So this is the method wherein exactly the arc can be quenched in the circuit breaker. So when I say that the relay is going to sense the fault and the relay is going to send the signal to the tripping coil is going to energize and it sends wherein the contacts of the circuit breaker are going to open. So once the contacts open, the faulty area has been isolated. So because of opening of the contact, there will be arc produced, but still the arc is not yet quenched. So what is the procedure to quench the arc? So here we are going to study the current zero interruption. We are going to make the current zero and we are going to interrupt the current and quench the arc. So the arc can be quenched at current instant zero. So this method is employed for arc extraction in AC circuits only. In this method, the arc resistance is kept low until the current is zero. When the arc extinguishes naturally and is prevented from restriking in spite of the rising voltage across the contact. We'll look at what exactly is restriking voltage and the recovery voltage and the rising voltage. So what it says that the arc resistance can be kept low until the current is going to reach its zero position. So as the AC voltage is sinusoidal, so it has to reach zero at many times at half of the way. So even the current also has to reach the zero at each half wave. So once the current reaches at 0 point, the arc can be quenched. So there are two theories to explain the zero current interruption of the arc in current zero interruption. One is the recovery rate, which is called as Slepin's theory. Second one is the energy balance, or called as Cassie theory. Recovery rate. So in this method, what we can see is that arc is just a column of ionized gases here. So in order to extinguish the arc, the electrons and the ions which are present in the ionized gases has to be removed immediately between the gap after when the current is going to reach its natural zero. So these ions and electrons can be removed by either recombining with some neutral molecule or by using some insulating medium, which can be gas, air or liquid. So in this method, the rate at which the gap recovers its dielectric strength, so the contacts, so the gap which is present between the contacts, the rate at which the gap recovers its dielectric strength, which is of the medium, is compared with the rate at which the gap recovers its dielectric strength with the re-striking voltage across the gap rises. Now, if the dielectric strength increases more rapidly than the restriking voltage, then the arc can be extinguished. If the restriking voltage rises more rapidly than the dielectric strength, then the arc cannot be quenched, or the arc does not quench. So arc will be still persisting. So it depends upon the dielectric strength of the medium which is present between the gap. Now energy balance. When the arc is finally quenched, the power again becomes zero. The gap is fully deionized. So the ions which are present between the gaps is deionized after the arc is being finally quenched. So in between these two, the power is going to increase. It is going to reach its maximum value. then decreases finally and reaches zero value as we can see in the figure. Due to the rise of the restacking voltage and the associated current, the energy is generated between the contacts, which forms a heat. So this generated heat has to be cooled as soon as possible by giving some blast of air or flow of oil at certain high velocity and pressure. Now, if the rate of removal of heat is faster than the rate of heat generation, then the arc can be extinguished. If it is less, if the rate of generation is more than the rate of heat dissipation, then the space breakdowns again and resulting in an arc for another half cycle. Right. So we'll be looking at what exactly is restacking voltage, the arc voltage, the system voltage, and the recovery voltage. So this is the system voltage waveform. This is the current. So the arc is quenched at zero position. So at this point, the arc is extinguished. So this is the arc voltage, right? So it is observed that at current zero, when the arc is quenched, so at current zero, when the arc is quenched, there is a very high voltage which appears across the contacts of circuit breaker. That voltage is called as a restacking voltage. So at the instant of current zero, arc is quenched. Because of the arc quenched, there will be a very high voltage which is going to appear across the contacts, and that is called as restacking voltage. Right? Once the transient voltage is going to die, once the arc is quenched, so whatever voltage is appearing across the circuit breaker is called as the recovery voltage. So at this current zero, the arc is quenched. So because of that, there will be a very high voltage which is going to appear across the contact, and that is called as restacking voltage, which will be a transient in nature. So once the transient voltage is going to die out after the arc is quenched, whatever voltage is going to appear across the circuit breaker is called as a recovery voltage. So the restacking voltage is the maximum voltage that appear across the contact of the circuit breaker at the instant of arc quenching, whereas the recovery voltage is the voltage which is going to appear across the circuit breaker contact after the arc is fully quenched and the transient voltage dies out. So this is what exactly is restacking voltage and recovery voltage, and which we have discussed in the method of current zero interruption. If you can understand the restacking voltage and the recovery voltage, and you can easily understand how exactly the current zero interruption method works, where in case of recovery rate and the energy balance. And so in today's section, we have discussed what exactly is the circuit breaker, how exactly the circuit breaker operates, and what is the fault clearing time, what is arc phenomena, arc voltage, the methods of arc extinction, and the restacking voltage and the recovery voltage. So this is the definition. After the arc is extinguished, the voltage across the circuit breaker contacts does not become normally instantaneously, right? But the transient oscillation is produced. So the transient voltage that appear across the breaker contacts at the instant of arc extinguish is called as restacking voltage. So the power frequency RMS voltage which appear across the breaker contacts after the arc is finally extinguished or quenched and the transient oscillation dies out is called as recovery voltage. That is what has been discussed in the previous figure. Again, these are the same definition. You can go through this. Thank you.